Hello students, welcome you all in Jagran Public School, Noida. Today I am going to discuss with you your next chapter, metals and non-metals. This is chapter number 4. In this session, we will discuss about the physical properties of metals and non-metals. So let's start our part 1 of metals and non-metals. So what are metals? Metals are mainly described as an element that have a capacity to lose electrons. Means all the metals element have the capacity that they can able to give its electron to some other metals or non-metals. So metals can be described as a chemical elements that readily lose valence electron to form a positive ions. So when an element loses electrons, it become a positively charged. That positively charged is called positive ions. Those material which possess these characteristics is called metals. And what are the basically physical characteristics of the metals are? Metals are being hard, they are shiny, they are malleable, they are fusible, they are ductile, etc. So all these terms we use with the metals. Few examples of metals are like iron, gold, silver, aluminium and copper. All of these metal as an element found in the earth crust. Some are found in the free state like iron, like gold, silver, platinum, but some are found in the combined state. Like iron, we can't found iron as it is in the nature. It is found in the form of hematite ore. Then we find out, then we take out the iron from that hematite ore. So some are free elements like gold, silver and platinum, but some metals are found in the combined state also. So this is a brass, act as a metal. This is a copper, which you are seeing on this slide, is a metal. And this metal can be used in different ways as below. In the form of pipe, in the form of screws, in the form of different shape. Now, what are the physical properties of metal? Physical properties means the things which you can touch and feel it. So first property of the metals is malleability. Malleability is the property of the metal which allow them to beaten into thin sheet. So when the metal can be beaten and be converted into thin sheets, that property is called malleability. And metals are malleable, means malleable is the characteristic of that metal and malleability is the property. Due to the presence of this property, the shape of iron nail and aluminum wire can be changed or beating. So due to this property of malleability, aluminum can be changed into thin foil. That is, you are looking in your diagram. Silver can be changed into very thin foil, which is used in the decorating purpose of the sweets. Aluminum foil used for wrapping food. This is all due to the malleability. So malleability means the change the metal into thin sheet. So this is the first physical property of the metal. Next is metals are conductivity. Metals are conductive means it is the property of the metal which allow the current and heat to pass through them. So metals are good conductor of heat and electricity. That is a copper wire. That wire can be used in different purposes for heavy wiring, household wiring, factory wiring, different type of. So the metals due to the good conductor of heat and electricity, the metals are used in different purposes. Ductility. Ductility is the property of the metal which allow them to drawn into the thin wire, which can be used, such as copper can be converted into thin wire and can be used as an electrical appliances in an electrical device, in an electrical wiring. Similarly, gold can be drawn into a thin wire and can be used in a different ornaments. Silver can be converted into thin wire. So all these property of the metal which can be converted into thin wire is called ductility. So metals having the property of metals are ductile. We can say metals are ductile. Ductile means it's having a property of ductility. Next is metals are sonorous. There is a shape of bell. This shows that sonorous means it can produce sound. It is the property of the metal which produces ringing sound. Ringing sound means if you hit a metal with another metal or anything, it produces sound. So metal having a property which can produce sound. So in all the metals, iron is considered is as a hardest metal which can produce a very hard sound. Gold is considered as a soft, aluminum is considered as a soft metal. They produce sound, but the most sound is produced by the iron. Next is lustrous. Lustrous means shining. So most of the metals having a property of shining. It is a property of the metal which makes them shine. And their structures are capable of reflecting incident light. Reflect means some light which is striking on the surface of the metal and it bounce back. So that is called reflection. Bouncing back of light is called reflection. So metal reflect the light or it shines. Most of the metal like gold, silver, brass, copper, all these having a great property of luster. So luster is a property which make the metal to shine. But some exceptions are there. First we studied that metals are very hard. But metals like sodium and potassium are soft. They are not much hard and can be cut with the knife. Look in the figure. This is the potassium and this is the sodium. We can cut the sodium with the knife. Sodium is considered as a metal. And we all learn that metals are very hard. But sodium and potassium have an exception that these are metal, but they are hard. Some are also liquid at room temperature, such as mercury. Mercury is used in the thermometer in the bulb and having a property that in a very a little high temperature, it expand, mercury expand on heating. That's why mercury is considered as a metal. So exceptions are mercury being a metal is a liquid, potassium and sodium being a metal, but it's very soft. Next comes to non-metal. Metal, we studied metals are hard, metals are ductile, metals are sonorous, metals are malleable, metals are, some are soft, some are liquid. Now what are the non-metals? So some materials like coal and sulfur are soft and dull in appearance. They do not have a shiny looking like metals. So they break down into a powdery mass on tapping with hammer. So when they are hammered like coal and sulfur, they turn into a powder. They are non-sonorous, means they do not produce sound, and poor conductor of heat and electricity. They are not a good conductor. For examples, non-metals like sulfur. Look at the figure. These are non-metals and sulfur is a powdered form. Carbon is a coal and carbon is a diamond also. Diamond is fully made up of carbon. So we can say diamonds is a non-metal because diamond is formed by carbon. Coal again is a fossil fuel and is made up of all the carbon content. So all these are non-metals. They are dull in color, only except the diamonds, but diamond is again a stone. After cutting the edges of the diamond, it reflects the light. That's why it appears as a shiny. But coal, sulfur, they are dull, non-lustrous. They do not produce sound. They can't be changed into a metal. Up coals, we can't make a sheet with the coal. We can't make a wire with the sulfur. So these are the conditions, these are the properties of the non-metal. Brittle. Brittle means anything which can be converted into a fine powder, can be broken down. Non-metals are generally brittle and hence cannot be beaten into sheets or drawn into wire. In the other word, non-metals are non-malleable, non-ductile. Where stress is applied on non-metals, they shattered into pieces. So they can be broke down when we hammered it. So basically non-metals are non-malleable, non-ductile, opposite the properties of metal. See, these are the non-metals: iodine, bromine, graphite, but exceptions are everywhere. Non-metals are gases or solid at room temperature, except bromine, which is liquid at room temperature. Bromine can be found as in the liquid state also. All the gases which are present in the nature like oxygen, carbon dioxide, nitrogen, all are considered as a non-metals. So non-metals are gases also. They are solid also at room temperature. Some are liquid also. Non-metals do not have luster. We studied in the previous slide, they do not have luster. But some non-metals like iodine and graphite have a luster. Graphite, which we use in our pencil lead, they have a shining appearance. They are bad conductor of heat and electricity, but graphite is considered as a good conductor. So exception is also here. Non-metals are brittle, that they are neither malleable nor ductile. This is true. Not a single non-metals can be converted into sheet. So non-metals are brittle. They are broken into pieces and they are neither malleable nor ductile. They can't be converted into sheet nor it can be converted into fine wire. They usually have low densities. Low densities means, density means number of atoms present per unit volume. Means atoms are not very closely packed in the non-metals. Like gases, you can consider a gases. In gases, all the molecules are loosely packed, having a low density. But if you consider an iron, in iron, all the atoms are very densely packed. So we can consider non-metals are low densities. Non-metals have low melting and boiling point. Non-metals are non-sonorous. They do not produce sound, any kind of sound. Non-metals are non-ductile. They are non-ductile because they cannot be melted and drawn into thin wire. They are brittle in nature. They are poor conductor of electricity. Non-metals are bad conductor of heat and electricity as they do not have free electrons. We studied metals have a free electrons. That's why they are good conductors. Electrons can flow. But in non-metals, they do not have a single free electrons. That's why they are considered as a bad conductor. But carbon, that is graphite, is an exception. Graphite is considered as a good conductor of electricity due to its spatial crystalline arrangement, and it is used in making electrodes. Electrodes, you will study further that electrodes conduct electricity. So graphite is used as an electrode, and being a good conductor, graphite is considered as a non-metal which is a good conductor of electricity. Non-metals are non-sonorous. Non-metals which do not make any sound when hit with an object, like phosphorus. Again, phosphorus is type of a rocks, red, it's a reddish in color. It's a non-lustrous. They are which are in the form of powder and gases. They cannot be polished and do not have any luster. If it is beaten with a hammer, it will convert it into a fine powder. They do not have any luster and can't not be polished and make it shine. Non-metals are generally non-lustrous and dull. Graphite and iodine are exceptions. You have seen in the previous slides that iodine and graphite have some lustrous property. They are lustrous as their surface possesses a shines. Graphite have a shining property as well as iodine also are some shining property. So in all the non-metals, exception is iodine and graphite. And being a conductivity, graphite being a non-metal is a very good conductor. Non-metals are generally powdered form, but some are in the gaseous form also, like carbon, like oxygen, nitrogen present in the atmosphere. They are also considered as a non-metal. So in every case, metals as well as in non-metals, exceptions are there. Softness. Non-metals are generally soft because they are present in the form of powders. Due to the non-ductile and non-malleable properties, non-metals are not strong at all. They can't be converted into wire, we can't convert into sheets, so they are not considered as a very strong. Carbon, diamond. Look at the diamond, how shining structure it is. It's very hard. Hardest material is a diamond, but it is an exception. It is considered as a non-metal. It is not a metal. Solid, liquid or gases at room temperature. Non-metals can be found in the form of liquid like a bromine or bromine, in the form of gases like nitrogen, in the form of solid structure like diamond, and in the form of powdered form like phosphorus. So in all the form non-metals is available. Non-metal may exist in solid, liquid or gaseous state at room temperature. For example, carbon, sulfur and phosphorus are solid, nitrogen and oxygen are gaseous, bromine is a liquid state. So in non-metal, all the three states like solid, liquid and gases are there. Non-metals being a low melting and boiling points. Non-metals having a loosely packed structure, therefore less heat is required to melt or boil them. So non-metals have low melting and boiling point. Non-metal possess low melting and boiling point except graphite. Graphites have high melting and boiling point. Carbon, that is graphite. Graphite is made up of carbon, is non-metal, but possess high melting point. So it is an exception in the non-metals. Basically non-metals, all non-metals have low melting and boiling point, but graphite is an exception. Graphite being a non-metal possesses high melting and boiling point. Low tensile strength. Strength wise means because non-metals are gaseous also, non-metals are liquids also, some are solid and in the form of the powdered form. So they have low strength, tensile strength. They are not as strong as metals and can easily be broken. After metals and non-metals, some are metalloids. What are called metalloids? The element which possesses the property of metals and non-metals are called metalloids. They are having properties of both metals as well as non-metals. So examples of metalloids are boron, silicon, germanium, arsenic, antimony, tellurium. Tellurium. See, these are metalloids which are having a properties of both. It contain both the property of metals and non-metals. So these are all. We studied metalloids, we studied non-metals, lots of properties of non-metals, It's liquid, gaseous, solid, and solid in the form of powder state. We studied its sonorous, non-lecherous properties of nonmetal. We studied that it is being a poor conductor, but graphite being a good conductor of electricity. It's a non-metal. Non-metals are brittle. It can be converted into fine powder like iodine also, bromine also. So these sulfur is also converted into fine powder. It's a brittle in nature. This is all the physical properties of non-metal. Non-metals are found in many ways like diamonds, coal, sulfur, different colors, different structure, but they are very dull in appearance. Metals also consider as a solid at room temperature, but some are very soft. They are solid, but some are very soft that can be cut with the help of knife like potassium, sodium. Some are in the liquid form like mercury. Metals basically having the property of sonorous and lustrous. They can produce sound. They have a shiny property, capable of reflect light. They are good conductor of electricity. They are ductile, can be converted into thin wire. They are malleable metals which can be converted into fine thin sheet. So this is all of regarding metals and non-metals. So metals are basically all the solid and available as a free element as well as in the combined form. Free elements like gold, silver, platinum, and in the combined form like iron, hematite ore, carbonate ore, different form of elements are available in nature. So just go through this metals and non-metals physical property properly. Check the video properly and try to understand the physical properties of metal and non-metal. In the part 2, we will study about the chemical properties of metal and non-metal. Till then, have a good day. Bye everyone.